Hi folks! Today I would like to talk with you about team structures, that is common team setups that we find in many organizations. To keep matters simple, I would assume that the organization has more than one team for software development, because if there's only one team, then obviously that one team does everything that is required in context. So let's just start with the assumption that we do have more than one teams. And this is the first setup that I encounter. The technical specialist teams. What we have is separate teams for analysis, coding, and testing. We sometimes see that this one is even scattered across multiple countries for efficiency from a cost perspective. For example, it could be that analysis is done in Western Europe, coding is done in Eastern Europe, and the testing part is done in India. So the three teams are set up to do their specific work, and they are not even in the same country, much less in the same building. Now, one thing that could happen is that those specialist teams do not even communicate directly with each other, so they would be completely separate entities who may not even interact at all. But of course, there is some kind of interaction required in order to successfully deliver software. So this kind of specialization, it looks very efficient because we have teams which can easily stand in for each other. Every analyst can do the work of every other analyst. Every coder could do the work of every other coder, and every tester could do the work of every other tester. And we can hire people who only know how to analyze, people who only know how to develop, and people who only know how to test. That opens a wide market and also makes it easy to bring a kind of a succession rule into the company. And that is why many major corporations adopt this model. The second model that I tend to see a lot in smaller organizations is the component specialist team. So you have a few people who analyze, develop, and test together on a component, a subsystem. For example, some take care of the CRM system and another team takes care of the billing and other financial systems. Within those teams, you have dedicated people who are specialized in analysis, some who are specialized in coding, and some who are specialized in testing. Again, we have the same advantage that we have for technical specialist teams. That is, we can tap into a wide job market because we're only looking for analysts with an analytical skill, only looking for coders with coding skills, and only looking for testers with testing skill. Sometimes we have people in component specialist teams who have a bit prior experience in one of the other domains, but we're not counting on it when we set up the team structure. The huge advantage of component specialist teams is that those people tend to know their components inside and out. They can tell you everything about what it is, how it does it, why it does it, where the quirks are, what the strengths of the current component are, and how to work with the component. That is a huge advantage over the technical specialist teams, where I often observe that they don't even know what the component really does. They only know what they are currently doing. The analysts don't know how the system actually works. The developers don't even know why the system does what it does. And the testers may have very little interaction with users, so they do not understand how the system is used. They only know how it works. In a component specialist team, we tend to have a different kind of outlook on the systems, in the regard that everybody on the team tends to have a pretty good understanding, because people inside a team, they tend to talk with each other and they know what concerns one another. A common pattern that is advertised in the Agile community as the next step up the ladder from the component team is the feature team, so that instead of having team A specialized on component A and team B specializing on component B exclusively, we have teams set up so that they can work on different parts of our system landscape and they can generate value end to end. There's a huge advantage of feature teams over component teams, and that is that Team A doesn't have to wait for Team B before integrating, and Team B doesn't have to wait on Team A before starting their work. The huge advantage of feature teams is that we have less coordination than we have in component teams. What is considered a downside from feature teams over component specialist teams is that they need a broader knowledge, so we need to spend more time ramping up the team. We need to spend more time to train new team members to be familiar with the system landscape, and we need to have people who are broader in their horizon across multiple technology stacks. Then finally I come to the fourth model, which is sometimes considered like the holy grail of software development, and that is the generalist team. The difference between a generalist team and a feature team is really only that instead of having people specialize in their technical function within the team, people are more generalist, both from a business perspective and from a technical perspective. So we have analysts who are familiar with testing, who basically understand coding. We have developers who also can analyze a feature and who know how to write their own tests. And we have testers who are able to not just work with the black box, but also with the white box to support the developers, and who collaborate with analysts to make sure that we're getting the requirements properly. The huge advantage of generalist teams is not only that we need to involve fewer people in order to get something done, but that everybody can involve throughout any time in the software development lifecycle. So we have fewer handovers between team members, and we have broader knowledge on everything that is happening within the team for everybody in the team. Many organizations still shy away from the generalist team idea because it's not so easy to find coders who are willing to also spend time in testing and who are able to also do analytical work. It's not so easy to find analysts who are actually familiar with the technology that they're analyzing for. And it's not so easy to find testers who have a very deep testing qualification and also understand both coding and analysis. Now, you don't need to hire people who have all those skills when they join the organization. Just say this is the way of working that we have in our organization when we onboard a new team member. Already during the recruiting process, we need to see whether there's at least a willingness to learn. Now, I personally would argue when people are not willing to learn, then we would eventually get problems anyway with those people. So say they are willing to learn, that is okay. We don't force a tester to become a hardcore Java developer within 2 days after hiring. That would not even make sense. Too much experience is missing. Or we can do a little bit of pairing to drag them in. We can have group analysis sessions where everybody gets together to say, let's analyze this feature request and see what we come up with, bring everybody's perspective in. And so people will naturally become more generalist. So generalist teams develop over time rather than simply being set up in this way. But we must send the signal from the organization and make sure that they are incentivized to do more than just one technical specialization. The massive advantage of generalist teams is that we will hardly ever get into a situation where we are blocked because this or that qualification. So for example, we have flu season and all of the testers are sick. It wouldn't even disturb a generalist team because we still have some people in the team who can test. The analysts can still do it, and the coders can at least cover for the basics. Now I would like to talk with you about a second topic, and that is how ideas flow from being conceived until value is available to the customer. Now you might think, well, we go through the software development lifecycle And we do that in all teams. So what's the difference? Let's take a look at how an idea arrives and how many hard handovers across team boundaries we have. What's the difference between a hard handover and a soft handover? Well, a hard handover is when you move information to people who might have a different mental model with whom you're not frequently interacting. The issue with a hard handover is that there's a huge probability that there are some misunderstandings, some information gaps, or anything else that could lead to a typical kind of telephone game where the difference between intent and outcome could be so significant that we're generating problems instead of solving them. So let's look at what happens when we're talking about technical specialist teams. The first thing, of course, the analysts will take a look at what is this idea and what does it mean for our business, how can we implement this kind of thing in a way that generates value. After the analysts have achieved a certain level of progress, the idea would move in an analyzed state into actual development, where the people who are doing the coding pick it up and realize the technical value. And that is the first hard handover. The analysts might have a different mental model than the coders, with the consequence that the code is only in a certain part addressing the actual need of the customer, and there are other parts that are covered either suboptimally or not at all because it was not communicated as important in the way that analysts did perceive the situation. After code has been generated and a deployment package is available for testing, testers will usually begin doing their tests in this model. Again, we have a second hard handover, so development tends to be either matured or even finished before testers see the actual product. This is the second hard handover, and the handover issue within this handover is mostly that any defects which are already in the product either get discovered by testers late, so they have to be handed back to developers for fixing, or are not discovered by testers at all, so they reach the customer, and eventually we get the typical kind of thing that we don't like to have, and that is the bugs in the production system which lead to incidents and problems which still need to be handled and disrupt everybody in the process again. So with technical specialist teams, we maximize the amount of hard handovers that are happening, with the consequence that we maximize the risk that we're doing stuff wrong. So let's take a look at how this one plays out in a component team. The component specialist teams, they only know their component, and typically we have an issue that adjustments need to be made in more than one system at a time in order to generate end-to-end value for the company. Going back to our simple example of CRM and billing, if we want to sell a new product, we have to make it available on the shop. We have to make it available in CRM so that customers can actually buy it and see the transactions that they're doing with it. We have to make it available in billing so that we can invoice our customers, and we have to make it available in fulfillment. That could lead to a lot of different teams having to pick up every smallest item. And I do remember working in organizations with just adding a new tariff for an existing product. So the only thing we're talking about is a new name and a new price. Of course, the old product still existed, but then you have the new product right next to it, which is different only in name and price tag. How many people have to get to work in a component specialist organization to deliver such a requirement to the customer? The number could quickly go to 5 or even 10 teams. I have seen organizations where in the worst case a small tariff adjustment, that happens for example in insurances and telecommunications a lot when you have complex system landscapes, then even such a seemingly cosmetic adjustment could take many months and dozens of teams getting to work. So you already see that The difficulty is the hard handover from the idea into the different component teams who have to get to work. The huge advantage of the component teams is that typically those teams tend to know exactly what they need to do within the scope of their specific component. Analysts will talk with developers and testers throughout the development process and tend to be able to deliver great results from the context of their own component. That is where we get into the challenge of integration. All of the component work must be integrated at some point in time. And that typically happens when everybody is finished with the work on their components. Many organizations, they have a separate integration test team that goes to work after all the components are finished with their work, which could be maybe half a year after the initial idea came into the teams. And imagine that if you are a marketing person whose need is to get this new tariff out to the market as soon as possible because the competition is $1 cheaper on our product than we ourselves are, it doesn't matter that it might have been the product that we created first. People tend to be pretty cost conscious, so they'll all go to the competition. And now it takes us half a year to get this new price out. What happens during half that year? We're losing potentially thousands, or if we're a corporation, millions of customers because we can't get this price out. So even if we have good harmony and good communication inside the team, component specialist organizations tend to struggle a lot with bad reputation within their own organization, and the organization as a whole tends to struggle with market reputation. So even though component teams are a kind of a step up from the technical specialist team, they still struggle with typical time to market issues that make it very hard for the business overall to succeed. And that is where the idea of a feature team is born. So how is the feature team practically different in communication from the component team? Well, we could have one central place where all the ideas come in, and we have a number of feature teams who all can work autonomously to get stuff done to deliver value to our organization. So the first feature team that has capacity to deliver this value to the organization is able to pick up this new idea, do all of the necessary adjustments, and deliver the product right to our customers. This sounds maybe a little bit easier in theory than it is in practice, because we need people to have a lot of deep and broad knowledge across multiple technology stacks. But once we are there, the first team that has capacity can pick up this new idea, they'll get together, they'll analyze it, they will create the code, they will test it, make sure that it's all integrated, ship it out, and we are done. And because it's all happening inside a team, we have the constant communication, all the information is present. Using good continuous integration, continuous delivery processes makes sure that the team doesn't mess up other teams' work, so whatever they produce is independently deliverable. And our time to market does not depend upon waiting for all of the component teams to do their work, because all of the work, without wait time, without delays, without information handovers, is happening all in one team. So we only have a few soft handovers. Analysts have to see what do our developers need, testers need to discuss with analysts how could this go wrong from a business perspective, could it go wrong from a technical perspective. So they'll take a look not only at what is my component doing, they're taking a look at what the entire end-to-end stack is doing and whether that is still consistent and meets the needs of the business and the customers. So feature teams already look like they're the holy grail. How could it even be a step up with generalist teams? Now my model was a little bit simplified, because we may not only have analysts, coding and testing as functions within our organizations. It could be that we have database specialists. It could be that we have Java specialists for doing the backend work, we might have front-end specialists, we might have UX designers, we might have architectural specialization. Testing might be separated into performance testing and acceptance testing. We might want to do a bit of security testing as well. And the consequence is that if we would want to have feature teams with all of the specializations on board, depending on how specialized we are, it could mean that we might need 30 or 40 people within a single team, and that just doesn't work, and which is also the reason why many corporations tend to have specialist teams. That's why it's also pretty hard to dissolve this specialist team structure, and even if we would try to move to component teams, we might still end up with a few internal handovers, for example from analyst, design and architectural teams towards the different coding teams who are doing front and back end database. And we might have different testing teams. One is doing the functional testing, another is doing the end-to-end testing, and then we might hand over to operations. So we still have a lot of handovers that are slowing us down. So the generalist team gives us the idea that, well, it would be too hard to say everybody can do everything, but what it means is that I'm a team member. I specialize in Java development backend. I can also do a little bit of front end. I can do some database administration. Not so much. If it gets critical, I should still involve the DBA. Of course, I know how to test my own code, and I know how to talk with the testers about what the risks of my code could be and give them the hints so that we can test the right things. And I take a role in analyst discussions as well. So I'm not only doing one thing, I'm doing multiple things with different degrees of expertise and different degrees of involvement. Depending on what is the need of my team. I might be doing 100% Java development if that is what my team needs. It could also be that this feature is extremely easy to code, just 2 or 3 lines, but it's dangerous in integration. So I'll just do a little bit of coding and spend the rest of my time to make sure that this one is properly tested. Could also be that we have a huge ambiguity of what is actually meant with this feature. So before even going to work on coding, I don't say that the analyst must analyze better. I'll just go to them and say, let's do this together. I have the following concerns. Let's have a few clarifying sessions with the stakeholders who need this thing, so that I am clear, and once I'm clear, I'm gonna get to work. This is a huge change in attitude, because I can no longer say this person over there is slow, that's why we're waiting. Because if they are there, I can't twiddle my thumbs and say I'm waiting for work. I'll just pick it up myself. What happens in generalist teams is that we tend to need a lot fewer people working together in order to get some business value out. Many simple requests, they really just involve a few small discussions, a few minor code changes, a bit of testing, and ideally not even any administration work. So we don't need to have a lot of people working on this thing, and it can be that smaller requests are picked up by very few people on the team and they're still able to deliver value. That could lead to shrinking team sizes, and it definitely leads to better communication, because if you have 2 or 3 people who say we take responsibility for this thing and we'll get it shipped to the customer, it typically tends to work out pretty well, and those people are in close, constant communication throughout the life cycle of this new feature request. I have worked in such teams, and even though we had a team of 6 people, what we did was a kind of a round robin, that one person was doing analysis and doing some prototyping in the code. Another person was responsible for the actual implementation, briefing with the analyst to make sure that they have the same understanding, while the third person was doing the testing part, discussing both with the analyst what are the right tests for this one, with the developer what are the technical tests which are required, and then doing exploratory tests on that new requirement as well. And even though it was kind of balanced from the amount of effort, the person with the analyst function typically was done first with their work. So they were still available for questions and clarifications, and they also did do a little bit of testing afterwards to make sure that everything was properly understood. But they would already be able to pick up something else which was analyzed by somebody else, and they could do the coding on this part. And we always only had 3 people working on the same thing at once. Our cycle time was like 2 or 3 days for a regular request, and we could get everything shipped with 0 defects for the entire time that I was working with this team. So now let us take a little look at what the different workflows look like in the different team constellations, how work flows through the system. So not just talking about how the value is generated, but how the work flows. If you have technical specialist teams, after it's planned, the first thing that we do with technical specialist teams is of course analyze it. Now, analysts do not always work perfectly at the same speed that coding and testing does. At this hard handover between analysis and implementation, the work is waiting to be picked up by a coder in order to be implemented. And depending on how different the speed between analysis and implementation is, it could be that we have perfectly analyzed requirements waiting for a few months to be picked up and implemented. Of course, things change during that period of time, so it could be that by the time it gets implemented, it needs to be reworked or it's already obsolete. Let's just ignore that for a minute. So something gets implemented and then we bring it to testing. Well, it tends to be the same kind of issue that happened with implementation already. Testers are always busy testing, and there's always too little time to do good testing. So instead of picking it up right away, it gets put into a waiting for testing queue, and testers will pick it up as soon as possible. In some organizations we do have delivery cycles, so everything is moving into the next testing cycle, and that could be from a single day to a few months until it gets picked up by testing. So what will testers discover in this model? Typically, because we have those hard handovers, something was overlooked by the people who wrote the code, or something was done wrongly, something was missing. We have all kinds of issues. We generate flowback in the form of defects, so the requirement moves back to implementation, at least for fixing, or in the worst case even for a redesign and re-implementation, which costs us a lot of time again. But at some point we do have the quality and the testing is done, and we can finally ship the product. What we typically see in the model of technical specialist teams is kind of like rolling waves, so that feature A is currently in testing, feature B is in a bug fixing phase, feature C is in implementation, and feature D is currently being in analysis. It looks like, well, how should it be different? Well, the issue with this one is that the analyst has to expect to be disrupted by features A, B, and C at any point in time for questions. The people doing the coding have to expect to be disrupted by features A and B at any time, so feature C could become slower, and so on. And this constantly happens, so the time that people are actually available to work on any one feature is not all that high. And because of all of the disruption, it creates mental load. Mental load creates stress. Stress leads to defects. Quality suffers. So we get even more flow back. So we get even less value into production. So the kind of problem that we're trying to solve, and that is resource efficiency, and all the analysts always have something to do. All the people doing the coding always have something to do, and all the tests always have something to do. It's perfectly solved, and we can add any amount of people, and we will still get into a situation where everybody always is busy, and there's always a lot of work waiting. This model, however, is not very flow efficient. And flow efficiency is if you take a different perspective. You don't ask how much percent of the time are people idle in this model, but you ask how often is an idea idle on its journey from conception to delivery. And as I already pointed out, there are those waiting periods and at times when we are working on flowback. All those time the idea itself is idle and not generating value for the organization. Nobody's working on the actual idea, and the idea is deprecating. It could very well be that the idle time of the idea on its journey is way over 90%, sometimes 95, 96%, and in some cases I've seen it being close to 99%. We are very, very resource efficient, so every person is always busy, but for the organization this is a terrible melody because we're just investing into people being busy without seeing any value in return. So let's take a look how this one looks in component specialist teams. And in reality, we might have kind of a mixed model that we have in larger organizations both the component specialization and the technical specialization. That just makes it even worse with more handovers, more weights, more status in our model and so on. Now the status model of each team is not so complex. We still have analysis, development, and testing until something is being released, but for the idea as an overall idea we must have a kind of a pre-analysis to see which team has to do what, and we need to have an integration phase where we integrate all of the work. And what tends to happen when we distribute work in a factory-style manner across multiple parts of the organization is that we get a huge amount of flowback. We get the kind of flowback from testing to development inside a team. That tends to be a little problem. We can still handle and manage it. But what happens is that we get flowback across the team boundaries. So the first kind of flowback that we would expect is that in a pre-analysis we said that team A would do X, team B would do Y. Then when team A is going a bit further and says this is how we're going to do it, and team B realizes this won't work out, it won't be compatible with what we're doing. So we're getting flowback already in analysis until we arrive at a consistent design. This one flowback also makes us slow and generates overhead. Finally, the teams can create their own piece of software and work with it and get it tested. And that usually is not so much of an issue, but better testers will already discover inconsistencies in design, and they also need to flow back to the other teams so that adjustments can be made. And then finally we get to the integration stage, and that is where we get all of the flowback, where we realize that everything that looked so good in theory doesn't really look so great in practice. And we might have to roll back large parts of the process and redo major portions. So in this model what we see is that the actual feature work starts to become insignificant in comparison to the work required to clarify and to fix the issues both in the code and in understanding that happen across the team boundaries. So the complexity in this model, which is hinted here, is not really in the implementation. It is in getting the same kind of understanding and fixing all of the issues that arise because we did not have this understanding but thought we had it. And that is exactly the problem that we're trying to address by setting up feature teams. Because we don't have all of this cross-cutting communication across team boundaries, our model really boils down a lot. The model of, we plan to see which team picks it up. Once it's in a team, it gets analyzed, it gets implemented, it gets tested. We might have the occasional defect, no issue. It's done, we can ship it. So we don't have all of those wait stages within our process, and we don't have all of the flowback and misunderstandings that might make things difficult across team boundaries. And finally, when we look at the flow of work in generalist teams, because we get together as the right kind of people who can pick it up and we say, We pull the work, we are ready, we have some capacity, we'll get it done. We're closely collaborating, and because everything is happening by the same people at the same time, why should we even bother with a more complex status model? We're collaborating anyways, and we're just trying to get this stuff done without delay. And because it is so fast usually for smaller things, it doesn't even make sense to do detailed tracking on in which status is this idea. I've had requirements and teams that were working more in a life cycle than in an initial product creation phase. You could do the implementation of a requirement within less than 1 day. So why track it at all? Just say we're doing it, then it's done. It's getting shipped. So we're doing great already. We don't need a more complex status model, and the flow is that we're picking it up, doing it, and done. Now, as we discussed in this video, you have different ways of setting up your organizations. Many larger corporations, they start with the technical specialist teams, and they generate a lot of coordination effort, a lot of misunderstanding through this kind of model. And if we even have component specialists and technical specialists, we multiply the amount of communication effort, or actually we don't. We just create communication debt, which is a different topic for a different video. And with this communication debt, we end up creating bad software that makes our customers unhappy, that doesn't deliver much value, and that hurts our business and our own credibility. But the advantage is that everybody's always busy, it looks cheap, so you get into the kind of idea, I'm not rich enough to buy cheap, but many corporations, they are rich enough to buy cheap. The step up from that one is to have component teams with end-to-end responsibility within their component, which typically leads to integration teams. The step up from that one is to set up feature teams, which require much more knowledge and understanding, deeper insights into what is actually going on. Also reducing complexity. And the best thing that you could have is the generalist teams, where a few people can do everything. The funny part here is that small companies, like my own, we don't even have a choice except to work with generalist teams, because we just don't have enough people so that specialization would make any sense. So it's a natural state where many smaller companies come from. Startups, they work in this way, and somehow on the journey towards corporation, towards the international enterprise, we lose sight of this and we think that it is not normal, but for every smaller organization it is. So instead of saying, okay, how can we make this long, deep transition, look for people who are able to work in a generalist way, give them the necessary means and support that they can work in this way, adjust the way that you're setting up teams, and just bring people together to work in this generalist fashion. I do not discredit the notion that there are meaningful reasons to work either as technical specialists or as component specialists. Just be aware of the downsides that you're inviting by moving towards this model. If anything at all possible, organize around products in product groups that are not bigger than maybe half a dozen teams. If it needs to be, don't try to go above a dozen teams, and make sure that those teams are set up as feature teams. So that is my advice for you, how to arrive at flow efficient teams that can generate high value with minimum overhead and with minimum delay.